Electromagnetic induction. In 1831, Michael Faraday discovered that a current can be produced in a conductor by moving it in a magnetic field. According to Faraday, when a conductor moves along a magnetic field, it cuts through the magnetic flux lines. This generates an EMF in the conductor, which gives rise to an electric current. The EMF so generated is called the induced EMF, and this phenomenon is called electromagnetic induction. Faraday observed two different points. Point number one, the induced EMF will be generated during the time when the magnetic field is changing. And point number two, the magnitude of the induced EMF is directly proportional to the rate of change of flux, or is directly proportional to the rate of change of the magnetic field. These 2 points are called as Faraday's laws of electromagnetic induction. This is a simple experiment to investigate the electromagnetic induction. Just consider a coil of wire wound on a hollow cylindrical frame. So this coil of wire wound on a hollow cylindrical frame can also be called as solenoid. The two ends of the solenoid are connected to a center zero galvanometer. And now consider a bar magnet, a powerful bar magnet. So there is a north and south pole. When the magnet is kept stationary near the face of the coil, the flux lines begins to flow into the coil. But no EMF will be induced because there is no change in the flux. At the same time, if you will keep moving the magnet towards the coil, then the flux lines passing through the coil changes. So this changing flux induces an EMF in the coil. Due to this, a current will be produced. So the current flowing through the coil can be detected by using this galvanometer. The galvanometer will show the deflection in the right hand side. So the pointer will move towards right. This deflection produced in the galvanometer indicates the presence of current induced in the coil. In this diagram, the magnet is pulled out of the coil, which means that we are moving the magnet away from the coil. When we will keep moving the magnet away from the coil, the flux lines passing through the coil changes. But the current will be induced in the opposite direction. And this induced current can be detected by using the galvanometer. And the galvanometer will show the deflection in the left hand side, that is in the opposite direction as that in the first case. And if you will pull out the magnet very quickly, the deflection in the galvanometer will be more. So the amount of current, it depends on the rate of change of flux. If the rate of change of flux is more, then the amount of current produced in the circuit will be more.